probably looking for a comprehensive, practical AI course. Believe me, you are finally in the right place. Hello everyone, welcome to this second episode of 8 videos long series where I'm gonna teach you everything you need to know to get started with the machine learning and AI. AI is the most exciting part of the programming. Every day people use it to build amazing own chatbots or autonomous driving cars. If you wanna be one of them, hit the like button, smash subscribe and get ready to build your new project, the weather prediction using classification supervised learning algorithm decision trees. Let's dive in. Let me show you the quick demo before we start. In this project, as usual, we will have some data set. I will show you step by step how to download the data set and explain you what we are doing. So don't worry if it's too complicated. It won't be too complicated. It will be divided into very understandable parts. There is also text next to the code, so we will just import the libraries, do some data preprocessing with the data set where the input features will be like the temperature, humidity, wind speed, and we will predict if it will rain that day or not. So data preprocessing, I will show you what to do with missing data, how to split data sets, train the decision tree classification model, and then test it with some final evaluation of our model. Once again, it will be simple and clear. Now it's time for the setup. All the code, the data set are viable in my GitHub. The link is in the description. It will be here. Classification. You can download the data set. And also here's the code. The same as I showed you before. Today we'll take a closer look at the classification supervised learning algorithm, more specifically on the decision tree algorithm. In classification, rather than predicting the exact number like the price of the house 84,000 euros, you predict the class where the data belong. To set up your project, open the File Explorer, create a new directory. I will name my directory the classification video. Open this directory, copy the path to this folder, open your favorite terminal and write cd, that stands for change directory, and paste the path of that directory. Press enter. Now we are in this directory. The directory is empty. But this ls won't work probably for you because it is a Linux shortcut and this is just write D or something like that, or just Google it. What we wanna do is to download the dataset from my GitHub, the temperatures predictions. Download the raw file like this. Open a new instance of File Explorer. Go to Downloads, drag and drop your dataset to the folder. Now you have the dataset set up, and the next thing is to open the terminal. If you haven't used the Jupyter Notebook yet, write pip install notebook, but I hope if you are watching the second episode you use it at least in the first episode. When you are in this folder, just write Jupyter Notebook and press enter. This will open the new instance of the Internet Explorer, and here is your dataset. And what you need to do is file new notebook. Kernel Python, yes. In this Jupyter Notebook, we'll write the whole code of this project. But before writing something, I will show you one more time the dataset In this dataset, there are 3 inputs: temperature, humidity, and wind speed, and we will predict to which class this row belong. If it's belong to the class 1, that means that day will rain, or if it's belong to the class 0, that means that in that day won't rain. That's the simple explanation. Now we can start with the coding. Open back your Jupyter notebook. I will just write the titles for my code. I will press here markdown. To write the title, I can put hashtag, and now I can write the title. Importing libraries. Press Shift Enter, or this little arrow. You see, Shift Enter. Here I will import the basic libraries you already know. The basic libraries you probably will use in every machine learning project and AI project. I will import NumPy as NP for numerical calculations, then pandas for works with the dataset, SPD, and the last one is import matplotlib.pyplot for the data visualizations, SPLT. The next phase is data preprocessing. Create new title, data preprocessing, enter, Shift Enter, and for the small titles you can write 2 hashtags, and this first one will be loading the dataset. Shift Enter, there's code. To load the dataset, I will use the pandas function. df stands for data frame. It is the common name for the dataset in the pandas. Pandas.read CSV, the name of our CSV file, which is temperature prediction. Predictions.csv. I will print out this data frame. Shift Enter. Something is wrong. PD is not defined. I haven't run the first cell. One thing, if you haven't installed these libraries, write pip install and name of the library into your favorite terminal. So for example, pip install numpy. Now I can run this cell. You see, we have the dataset with the 3 columns, and if it's rain, and our output column, which decide if it will be raining or not. In our dataset there are 2 columns which represent the order of our data. We don't need 2 of them, so I will alter this dataset a little bit, just writing df is equal to df integer location, and with this you can do the data frame slicing. The first is you will take all the rows from 0 to the infinity, and the last one will be take all the columns but not the first one. When I print the dataset now, the data frame now, it deleted this unnamed column with the order, and we have only the order of our pandas data frame. In this data frame you can print out the, for example, data frame shape, print the data frame the name of the columns and stuff like that. As you can see, it has 100 rows and 4 columns, and the columns have name temperature, humidity, wind speed, and rain. I hope that this is working for you, and we can move on to the next things. As you know, as I said, in this dataset there are input features and output feature, so I need to split this dataset into 2 datasets with the input and with the outputs. I will create a new title, smaller title, splitting dataset into inputs, dataset, and outputs dataset. Press enter, and I can do it with the same method, the iloc from the pandas integer location. Capital X stands for the inputs fixture is equal to data frame that ilog, and from this data frame I need all the rows and I need all the columns except the last one. The outputs will be the same, data frame, integer location, and from this data frame I need all the rows and only the last column. Now I can print the input features and the output feature. Here are the dataset with our inputs, and here are the dataset with our outputs. With the closer look to our dataset, you can notice that there are some missing data, not in a number. But what can you do with this missing data? I will show you. I will create a new title, the smaller title, missing data. And what can you do? You can just delete the rows, because if there is like 2 rows with missing data, you have all the other rows to train the data set, to test the data, to train the model, to test the model. Or you can just put the value instead of this, not a number. What value can you put there? For example, the average of other values, or the mean, the most frequent values. And how can you do it? For this, there is a class, the sklearn, is very useful for the deep learning, machine learning, and all algorithms like this. From this library, from that sklearn that impute, I will import the simple imputer. You can find this library in the documentation of the sklearn. You see sklearn.impute, that simple imputer. So from this class, import this class, this subclass. As you can see, invariant imputer for completing missing values with simple strategies. You can put here many parameters, but I will show you only this: missing values and strategy. We'll use exact strategy. The mean and missing values are not in numbers in our dataset. You see there are few of them, like here, like 2. So maybe the good idea would be like delete these rows, but I want to show you some other techniques. For this simple imputer, I will create an object of this class. The mean imputer is equal to that class. The simple imputer is the name. I will check one more time. Simple imputer. Okay, this should be correct. And I will copy this. The missing values are not the numbers. I will create it is in our case numpy, not the numbers, just to make sure. This mean imputer I need to train on some data. I will fit it on the X training dataset of this one, and missing data are only in this column. For this reason, I will put here the ilog, all the rows, and only from the first one, only this second column, because in Python the indexing is from 0, the first is counting, and the last is not included. So only the humidity is included here. You can fit it on the whole dataset just writing X, but it will result the values with floating numbers and some weird resolution of the final result of the final dataset. So this is the better way. It was just a try and error. Now when I have fitted this object, I have trained that object, I can write here that new X will be equal to the mean imputer that transform our old dataset. This, and I want to transform only the humidity column. Now I will print out if it's working or not, and as you can see, it is working. In this dataset, the not a number was the 98th row, and here is number the mean, the average of all the numbers that are in this humidity column. Now we have one inputs and one outputs. We need to split this data into the training set and the testing set. And we do it after handling the missing data to remain the consistency of our data, because if we do it later there could be like some missing data in our testing data set. It doesn't make like really a sense to do it twice, or it will be just weird. There are many more reasons, but it is like a difficult topic. But to remain the consistency is just good answer. Splitting the dataset into training and testing datasets. This will be the markdown. And from here I will use another class from the sklearn documentation, from sklearn model selection, import train test split. This is function. This is not the class. You can look up this train test split also in the documentation of sklearn. I won't show it today. To use this function you write 4 datasets, the training inputs, the testing inputs, the training outputs, and the testing outputs. Now you will use the function train test split. Here you will input the input features and the output feature. Test size is the percentage of your dataset that goes to testing dataset. I will put 0.25 because it's a convention to do it this way, and it is like good ratio if you have like small dataset, because if you have like 1 million features you don't need to put like 25%, you can put like 5%. But I have only 100 columns, and the random state will be, for example, 42 to make the result. Now I will print the xtrain and also the xtest, and you will see it is randomly chosen the values. It is not like first 75 is training set and last 25 is testing set. So it is randomly mixed. The next step is training the decision tree algorithm. Shift enter, and before the code I will explain you how does the decision tree algorithm works. Here we got an example of plotted dataset, and a decision tree algorithm will cut the dataset in several iterations into smaller parts in order to maximize with these splits the number of points from the same category in this subpart of the splitted dataset. This is a very basic way to explain it. In reality it counts some entropy and complex mathematical operations, and if you wanna know more I will leave a video in the description so you can watch it with the whole theoretical explanation how does the decision tree algorithm works. For these decision trees there is also another module in sklearn library. From sklearn, I cannot write, sklearn that tree import decision tree classifier. You can look at the classifier in the documentation, decision tree classifier, and I will use this criterion. This is the criteria for making the splits. Classifier is the object of that class, as always. Decision tree classifier, we need to initialize that object. The criterion will be equal to the entropy. That's the mathematical concept. You can get to know this concept in the video I mentioned in the explanation. In the random state to make the same result between me and you, I will put the random state same as you will put. And here classifier, I will learn this classifier with the feed method on our train data with the corresponding outputs. Press enter. The classifier is created. What the last thing is missing is here markdown and making predictions. This prediction is basically testing accuracy of our model. For this, there is also predefined the function in our module, the decision tree classifier. You can use the classifier that predict and the values like this. Print classifier predict the values, and as an input to this predict function, the classifier expects the 2D NumPy array with the values. I will find the testing dataset, which is here. For example, the fourth row, copy the values, comma, and the next value, where is it? It's here. The humidity is very high, the temperature is very low. The wind is 3 kilometers per hour or something like that. And if I print out this prediction, it will do a warning that X doesn't have valid features names, but it will print out the out. If we check in our dataset, the fourth row is this one with a no, which one is fourth? Okay, the index in our Jupyter notebook is from 0, so the fourth one is like 0, first, second, third, fourth one is low temperature, high humidity, wind speed 3 of some units, and it is really raining. So our model predicted it correctly. But we don't need this warning. How to get rid of it? You can define the input data for our predict method, create the pandas data frame, copy these values, comma, columns are equal to the temperature, humidity, and wind speed in the list. Temperature, humidity, written humidity, okay, correctly, and wind speed, capital S. Close the list, run the code, everything is fine, and now we can print out the classifier, the predict, and in that predict I will put the input data. It is the same 2D NumPy array, but with the name of the columns. The prediction is 1. But we don't need... This is amazing, we predicted one value with our decision tree algorithm. The next step could be like predicting all the testing values from our test dataset and compare them with the values in the beginning dataset we have here, temperature predictions.csv, and compare how many values will be correct. For predicting all the values, we can use the same method predict from this classifier object. I will use the ypred, we will have prediction values for our test dataset will be equal to classifier predict the values of the whole test dataset. Now I can print out the predicted values, which are this. This is the classes where our rows belong. Rain, not rain, and so on. If I print out our y test, which is the real values of our test dataset, it is in row. And what we need to do is concatenate these two datasets and compare them. I can use the print function to print it out, and numpy.concatenate these two into two rows, and I can do it like this. I will create two columns, the one column from the ypret, one column from the ytest, and connect them together on the column axis. So this concatenate function takes two arguments, like these two, and then from which axis you wanna connect them, I will show you later. So the ypret, I will make reshape method from here, reshape. The number of columns, the number of rows is the first argument. It will be the length of that dataset, and number of columns will be 1, comma. The second dataset I wanna connect with this ypret is ytest. Also reshape to the length. The number of rows is length of the ytest, and number of columns is 1. Close this one. And the second argument, this is the first argument. This is the first argument of the concatenate, and the second argument is 1, because it is like 0 is for rows and 1 is for columns. So we need to concatenate these two datasets on the columns next to each other. Enter. And as you can see, we got the values. There are some differences, but most of them are similar. So our model is predicting like good, but it's not perfect. To evaluate how perfectly is our model predicting these values, we can use something which is called confusion matrix. The confusion matrix, as you can see in the picture, is a table used to evaluate the performance of a classification model. It shows 4 key metrics. True positives, the cases the model correctly predicted as positive. True negative, cases it correctly predicted as negative. False positive, cases it correctly predicted as positive, also called a type 1 error. False negatives, cases it incorrectly predicted as negative, also known as type 2 error. By analyzing these values, you can calculate the important metrics like accuracy predictions and more other that will help you to understand how the model is performing. If you wanna know more, I will also let the link for more in-depth explanation of confusion metrics in the descriptions down below. That will be our last code to do the confusion metrics. Confusion metrics. Enter and write the code. There is also another module in sklearn. You see, sklearn is very useful from sklearn, and still I cannot write this name. From this sklearn metrics, I will import the confusion metrics, and first argument will be the true values, and then will be the predicted values. Metrics, import confusion metrics, and print out these confusion metrics on the real values ytest, comma ypret. Print out invalid syntax. Import this ytest is not defined. I need to do the y, not x. This. So it correctly predicted like 7 positive, and I correctly predicted the 7 negative. Other are incorrect. So our model is not really that good, but it is like 50-50. So it's this time our model predicted the values like in average, so it's not very accurate. But if you wanna try the predictions with this dataset on different classification models, this could be a good way to improve and find this another way how to do the classification and try to have better accuracy of your model. This will be the task for you. These are the true positives and these are the true negatives. So these are the correct values. To make a quick recap what we have done in this episode, we have learned the next supervised learning subcategory, the classification. We tested it on our weather prediction dataset and project. We do a lot of data preprocessing. The new thing is you know what to do with missing data, you know how the decision tree algorithm work for classification, and you can predict new values. And you also know how to evaluate these values with confusion metrics. All the important links are in the description. You can join my Discord channel, which I will try to renovate and make it more usable for you guys, so you can find friends to code with or some funny and important information about machine learning and AI. And if you like this video, hit the like button, smash subscribe, share this video to your grandma, Telegram or something, and enjoy the rest of your beautiful day. Peace.